So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 359, and in this video we continue with our user-defined conversion function. And again, here in CPP reference.com, you go here to down to expressions, and here you can find user-defined, but you can also go here to classes, to the converting constructor, and here in the converting constructor you can select this one, a user-defined conversion function. And the reason for that is now you can switch back and compare it with the constructor here. Okay, now we scroll down to the examples. We have already covered this example, and now we start with this example here. And first we read this text here together. It says in the first paragraph, user-defined conversion function is invoked in the second stage of the implicit conversion, which consists of 0 or 1 converting constructor or 0 or 1 user-defined conversion function. And here a side note where it says function is invoked in the second stage, there is a ranking which is the compiler using. This ranking system is a separate topic. We continue reading here. It says if both conversion functions and converting constructors can be used to perform some user-defined conversion, the conversion functions and constructors are both considered by overload resolution in copy initialization and reference initialization context, but only the constructor are considered in direct initialization context. Here the important part is that we have to learn how the compiler is choosing which conversion, and important is also this part here that the compiler can only consider in a direct initialization the conversion constructor. But we will learn this now here with this example more in detail. It says here struct2, so we are going to create a struct called 2. And we see the struct has here a default constructor. Important note here, we use here explicit the word default, which means we want that the compiler provide us a default constructor, and it should optimize it and make it available for special cases, for triviality and more other things. The next line is a converting constructor, but let's analyze this one as well because there is something special. Starts with the name like old time constructor, then it starts with cons. We know the word cons has here different meanings. For example, we can bind later here a PR value, for example, and it means of course read only. But now we have here the word struct, and this is something new. We have not talked about this one, but this here is a forward declaration. Normally you would not even write the forward declaration here because this is not very visible. They write a forward declaration most time here on top. They take the struct and the class and put it here on top. But what is a forward declaration? It means that the compiler just don't know that you have already created a class, or in this case it's a struct with the name form. And because the compiler don't know this, you have to write a forward declaration. This can work, but it is important that you provide this information later. In this case, it is provided here just below. And remember that this converting constructor here is a implicit converting constructor because we are not using the word explicit, and that means that the compiler is allowed to use this converting constructor later to convert from one type to another type without informing the programmer. Okay, and let's go to the next part, which is again a struct with the name form, and this struct has only one function. It is our conversion function, and the conversions function here starts again with the word operator. Then we have the return type 2, so we are converting to the struct 2 here on top. Then we have here the word const, which means just don't modify anything here in the body, read only. Then we are returning, and we can see we are returning a temporary object here, which we create with the struct 2. Also remember that this conversion function here is also not using the word explicit, which means this conversion function can perform an implicit conversion, so the compiler can choose it again without noticing the programmer and convert from one type to another type. Here are very important information to the word implicit in this context. Many use the word implicit in front of the converting constructor or the conversion function when they don't want that that the compiler is performing an implicit conversion, because this can cause also bug when the compiler is trying to find a conversion where you don't want that the compiler is performing a conversion. Okay, and now let's see this all in action. We go to the main part here. We start to create an object from the struct from. This is this one here, and we know the struct from has just a conversion function. Okay, and now we go to the next line and we see we are going to create here also an object called t1, but we are using the struct2, and the struct2 here on top has a default constructor and a converting constructor. This object creation here is using direct initialization. We can see this here under round brackets, and the direct initialization can take an argument which is here f, which is our struct from. Okay, and here the compiler has now two options. Convert this. The first option comes from the struct2, and here we know it is the converting constructor. The second option comes from the object itself. It is f, and f is a type of from. It is the struct from here, and here is the option a conversion function. So what is the compiler now choosing? And in the comments here we see this already. It is choosing the direct initialization, and that means it's calling the constructor here on top from 2. The question is why it is choosing that, and the answer is here on top. When we read the last line, it says here the constructor will consider in direct initialization context the constructor if available. Interesting is the next few notes here down, because it says here if the converting constructor here on top is not available, then it will still not choose the conversion function here, even this one is available. Instead, it is creating here a implicit copy constructor here in struct2, and we know our copy constructor is expecting the same type of the struct, which is a 2 as a parameter. This parameter must be prepared now by the compiler from this syntax here, but we have only f here, not the parameter 2. In this case, the compiler says, okay, now I go to f, to the struct f, and I find here the conversion function. I take this conversion function, create the type 2, and then I pass this created type here to the copy constructor. Here a side note to this part here, you can see that this knowledge is only important later when you use debugging. For example, here is anywhere a bug and you don't know why the compiler is not choosing a conversion function, and then you have to know something like that the compiler is not even considering this kind of function because it is just not allowed and has to find other ways. Okay, let's go to the next line. It is commented out, but the syntax is this part here, and it says here we create another object called t2, again with the struct2 type. Here we are assigning f again, but this time we have an equal sign. That means we make a copy initialization, and it says here ambiguous. Okay, and the question is why it is ambiguous, and the answer is here on top again in the first part. It says here the compiler can choose a converting constructor or a conversion function in copy initialization. Of course, there are other candidates too, but here we have a copy initialization. Okay, a very important information for this line here, and that is this one is no more true. It is no more ambiguous, because in later versions of the C++ standard, this is fixed. And when you test this now, let's say you put this in an IDE or online forum and comment this out here and run it, it will compile. Okay, that's enough for this video, and like all time, if you have any questions, write in the comment section. See you in the next video. Bye and good luck.